Evaluating the ballistic missile defense system is one of the most demanding test endeavors ever attempted by the Department of Defense. This complex and challenging endeavor requires a sophisticated team effort as the Missile Defense Test Program builds confidence in the BMDS with civilian and military leadership and the populations this system will protect.
The complexity of the missile defense architecture drives us to have a test program that is global in nature and expansive over a large area. And so therefore it's going to be a very comprehensive test program to begin with, but we must test to the level that we have confidence in the operational effectiveness, suitability, and survivability of this system.
Testers subject each system element, Aegis BMD, ground-based mid-course defense, terminal high-altitude area defense, missile defense sensors, and command, control, battle management, and communications to rigorous testing. They must also integrate all these elements into a land, sea, and space-based system that is dispersed over a wide geographic area that spans multiple time zones. In Flight Test 5 of the ground-based mid-course defense system, elements of Aegis BMD, sensors, and battle management, MDA conducted the most complex system test to date.
FTGO-5 was our most complex test to date because it represented the entire missile defense architecture that we have employed into the Pacific region.
On December 5, 2008, testers demonstrated a significant milestone by integrating space sensors, land-based radars at Juneau, Alaska and Beale in California, and sea-based sensors on board Aegis BMD ships and on the sea-based X-band radar. MDA launched a target missile from Kodiak, Alaska, and an interceptor from Vandenberg Air Force Base in California. The battle management was conducted through the command and control node at Colorado Springs. It managed the flow of data among the system elements, making it possible for the exoatmospheric kill vehicle to collide with a 4,000-kilometer missile. And all of this occurred within a matter of minutes.
Hit-to-kill technology does work. We've proven it in different means, short range, medium range, and intermediate range threats. When we tie our testing together, we test air, land, sea, space, cyberspace, and we've tested them to the point where we have confidence that when integrated, we have an excellent capability.
Given these challenges and the expense of flight testing a system as complex as the BMDS, the Missile Defense Agency is developing more cost-effective ways to validate the system's operational effectiveness, its suitability, and survivability. Missile defense testing is so expansive and complex that MDA cannot rely on flight tests alone. Models and simulations must play a large role. In early 2009, MDA is working in partnership with the BMDS Operational Test Agency and the warfighter community to revitalize the Missile Defense Test Program and make it more affordable.
Part of the OTA team's responsibility is to work in conjunction with our MDA counterparts, hopefully to make the missile defense system the best possible system it can be. We get involved early, help design the tests that need to be run, to see the data that we need to gather, to make the judgment calls, to provide an independent assessment of performance.
Using criteria supplied by the OTA, the warfighter, and MDA system engineers, ground and flight tests are designed to provide data that MDA and the operational test community use to anchor models and simulations and verify system functionality and operational effectiveness. The goal is to validate models and simulations so that independent testers and warfighting commanders have confidence in the predicted performance of the BMDS.
Models and simulations allow the decision makers and the stakeholders to predict the performance of the system within its current design space. It will also allow you, when the models are properly anchored, to extrapolate beyond the design space, and some examples are man-made and natural environments, larger raid sizes, or even threats that are well beyond the design space. A good example of this was the satellite shootdown that we did with the Aegis system, in which we used anchored models to predict the performance of the system and make recommendations to the President. When properly anchored to real-world test data, it allows you to have a model that actually represents the real world.
The BMDS Comprehensive Test Review is being conducted in 3 phases. In Phase 1, MDA and the Army, Navy, and Air Force operational test agencies studied the models and simulations, and determined the data needed to accredit them using a comprehensive verification, validation, and accreditation process.
CNIP is tracking.
UEWR is tracking at 123.
This process involves verifying that models and simulations reflect the physical system, validating that the model represents its real-world intended use, and accrediting that the model or simulation is acceptable for its specific purpose. But this is not enough. Despite this desire to rely on models, they cannot provide all operational performance measurements required to assess the system. Much of the data needed to understand system survivability, reliability, performance in extreme natural environments, and supportability can only be measured through ground and flight tests. In Phase 2 of the test review, test objectives and scenarios for a campaign of flight and ground tests are under development. Testers prioritize test designs based on requirements to determine the system's capabilities and limitations and the need of the combatant commanders to field a specific block of missile defense capability. Data from these tests are fed back into the models and simulations in order to make them credibly reflect system performance. These test objectives will not only address data necessary to validate the models of individual missile defense interceptor systems, but will also demonstrate the performance of the BMDS working as an integrated system. During Phase 3 of the review, to be completed by the end of May 2009, the funding and infrastructure needed to implement the test campaigns will be addressed. A key cost driver will be the ability to establish an inventory of reliable targets to satisfy test requirements over a variety of flight test regimes. The test program maintains a strong adherence to system engineering principles and assesses all aspects of the missile defense system performance.
Launch enable keys to system arm 3, 2, 1. Mark. Check missile 1.
DGS-1 verifies interceptor 1. Go for launch.
Attention all personnel. Stand by for interceptor count pickup.
5, 4, 3, 2, 1.
Missile 1 away.
TD, interceptor 1 away.
Copy.
Engaging track 2001 on my mark. 3, 2, 1. Mark. Track 2001 engaged.
MDA conducts flight tests using assets in operational configurations in order to initially test each element individually and evolve that testing to more complex end-to-end tests of the system. Each system test builds on the knowledge gained from previous tests and adds increasingly challenging objectives. As the flight test program progresses, each test becomes more operationally realistic, limited only by environmental and safety concerns. During 2008, the integration functions of BMDS elements, such as track correlation, were repeatedly tested in GMD, Aegis BMD, and THAAD flight testing, and system ground testing. Comprehensive ground tests of the elements and components precede each flight test. Each ground test campaign weaves together element hardware-in-the-loop tests and high-fidelity threat simulations to test our capability across a wide range of threats and environments that cannot be affordably replicated in flight tests. Some ground tests use operational hardware in a laboratory environment, and others use the actual operational assets controlled by uniformed operators in the field. During ground testing, warfighters operate the system to exercise and evaluate the human-machine interface and develop tactics, techniques, and procedures.
We have a quick alert.
Copy, got a quick alert.
Aegis is in track.
Other important test evaluation activities include capability and readiness demonstrations, combatant commander exercises, and war games.
Roger that. Standing by for statuses.
We have acquired Missile Acquisition Search Commands.
TFCC, this is Radar 2. Be advised, we have received Missile Acquisition Commands. Over.
MDA conducts operational testing in coordination with the Director of Operational Test and Evaluation. As the office responsible for providing an independent review and analysis of test results, the Director of Operational Test and Evaluation performs an important oversight function, ensuring that the BMDS is operationally effective and suitable for combat use. As the advocate for missile defense, U.S. Strategic Command, in collaboration with the other combatant commands and joint staff, uses the BMDS test results to assess and prioritize development of future missile defense capabilities.
It's important for the warfighter to be involved in missile defense testing because this gives the warfighter the opportunity to shape the test, to establish the objectives that he or she wants to see in this test. And that's very important because they want to see it tested in all of the operational environments. So once they see that, they understand the limitations, they understand the capabilities of the system, and that gives them the confidence that on the night they need to use the system, the capability is going to be there.
U.S. Strategic Command also uses these results to perform military utility assessments to determine the capabilities and limitations of the system when they are considered for contingency deployments. As part of this continuous test cycle, once the test results have been analyzed and then shared with the Director of Operational Test and Evaluation and U.S. Strategic Command, they are injected back into the testing process. This further refines models and simulations and the ground and flight test campaigns. Missile defense test results also send a very credible message to the international community, to allies and adversaries alike, on our ability to defeat ballistic missiles in flight, thereby reducing their value as weapons to threaten our friends and allies.
My vision for our future testing process is, number one, it's very rigorous, and number two, it is collaborative with the operational test agencies so that it can inform with significant confidence to our combatant commanders, Department of Defense, and the senior leaders of our government, including Congress, that we have accurately characterized the performance of this system as an integrated ballistic missile defense architecture so that future decisions made on the employment of the system are done very effectively to counter the proliferation of ballistic missiles that we see occurring across the globe.
There is much more work needed to ensure the fielded system performs as intended. Testing is a continuous evolutionary process. Robust and comprehensive missile defense testing plays a critical role because the Missile Defense Agency will continue developing the ballistic missile defense system as long as the proliferation of ballistic missiles continues.